everybody. Today we're going to be doing a nice little analytic geometry problem. Namely, we're supposed to find a value of the parameter k such that the circle x squared plus y squared plus 1 minus 5k times x plus 4 minus 2k times y, which is equal to 5k, is tangent to the x-axis. Now, the general equation of any circle is given by x minus x center squared plus y minus y center squared is equal to r squared, where x and y are just general coordinates. Okay, and now general coordinates. X is the independent variable and y is the dependent variable, while xc and yc are the coordinates of the center of our circle, and r squared is the radius of the circle squared. Now, if we want to excuse me. Now, if we want our circle to touch the x-axis, we know that yc must be equal to r. So instead of yc, I'm just going to write y minus r, everything squared, is equal to r squared. Now, with that in mind, we can go back into our given equation and simply complete the squares. So x squared, and I'm going to write these parts first. So x squared plus 2 times 1 minus 5 over k, 1 minus 5k over 2 times x plus these parts right here plus y squared plus 2 times 2 minus k times y is simply going to be equal to 5k. Okay, so I rewritten our original equation in a slightly different form. Why? Because I want to complete the squares by using the binomial theorem. So a plus b squared is equal to a squared plus 2ab plus b squared. Okay, so in the first part this is a, and in the second part this is a. Okay, these are actually going to be b's. In either case, we're supposed to add, so I don't have room right here, but we're adding 1 minus 5k over 2 quantity squared plus 2 minus k quantity squared to both sides of our given equation. So on the left hand side we'll have we'll have this form right here, but I'm going to go ahead and convert it to this form right here. So on the left hand side that's going to be x plus 1 minus 5k, 1 minus 5k over 2 quantity squared, and for the second part I'll have y plus 2 minus k quantity squared is equal to 5k plus 1 minus 5k over 2 squared plus 2 minus k squared. Okay, so this part right here must be equal to r, and this part right here must be equal to r squared. So by squaring this part and setting it as equal to this part, we'll find our value of k. So 2 minus k squared is equal to 5k plus 1 minus 5k over 2 squared plus 2 minus k squared. Okay? So 2 minus k must be equal to this, and of course we can just go ahead and cancel these two out. Very nice. Okay, so from here we get that 5k plus this part right here, and I'm just going to expand it, plus 1 minus 10k plus 25k squared over 4 is equal to 0. Let's go ahead and multiply everything by 4. That will give us 20k plus 1 minus 10k plus 25k squared is equal to 0, or 25k squared plus 10k plus 1 is equal to 0. And now k is going to be equal to minus 10 plus minus b squared minus 4ac, which is 100, minus 4 times 25, which is the same as 100, and everything over 2a, which is 50. This, of course, cancels out, so that means that we have a single value of k, and that value is equal to negative 1 over 5. Okay, so that is our final answer to this problem. I hope you enjoyed the video. If so, leave a thumbs up and subscribe, and I'll see you in the next one.